as requested, here are a few solutions to the homework packet. I'll cover 10, D, E, F, G, and G number 2, and also problem 11. So for each one of these limit problems, the idea is to follow the flowchart. If it's a continuous function, you can plug in the value to see what the limit is. If there's a discontinuity, you have to use algebra, either the equivalent function theorem to fill a removable discontinuity, or you can think about the left-hand and the right-hand limits to see if there's like an infinite discontinuity. Are you going to infinity or negative infinity, or maybe it doesn't exist? In cases where we're looking at the end behavior, think about whether or not the numerator is growing faster than the denominator or vice versa. So for this one, as I imagine x going to larger and larger negative values, those will become positive when I square them. So we know that the numerator here is always going to be positive values. The denominator here, because it's an odd function, is always going to be negative values. So overall, this whatever magnitude this quantity has, it should be negative because we're going to have positives divided by negatives. All right, well, what's happening to those magnitudes? Is it the case that as x gets very negative, they're approaching a fixed value, or maybe 0? Well, since this numerator function is 3 to the something very, very large, that's growing much, much faster than the x to the 5th term. So this term dominates. So that implies that this whole limit must be approaching negative infinity. Here's what the graph looks like, and as we can see, as the x values get more negative, the graph very steeply decreases. So it's headed towards negative infinity as predicted. All right, what about this one? Well, I have this gut feeling like with cosecants and cotangents, maybe this can simplify somehow. So I'm going to rewrite cosecant as 1 over sine. I'm going to write cotangent as cosine over sine. And then I'll simplify this further. So now I've got sine x divided by sine 3x times cosine x. So don't be tempted to cancel the signs because they have different frequencies, so we can't cancel them. You could maybe rewrite sine 3x in terms of sine x's and cosine x's if you happen to remember how to do that kind of thing. I'm not even sure that's necessary because as I look at the limit here, I want to know, does this happen right at a discontinuity? Because if it doesn't, then I can just plug in the value here and it should tell me what the limit equals. So let's try that and see what happens. So let's just remember 7 pi over 6. 6 pi over 6 would be here, so 7 pi over 6 is approximately there. The sine of 7 pi over 6 should be negative 1/2. Cosine of 7 pi over 6 should be negative root 3 over 2. So far, so good. All right, what happens when we multiply this by 3? That's just like saying 7 pi over 2. So this will be sine of 3 times 7 pi over 6 is 7 pi over 2. So where's 7 pi over 2? Let's see, 1 pi over 2 is here. So 1, 2, 3, 4, 5, 6, 7 is down there. So the sine of that angle, 7 pi over 2, it looks like should be negative 1. So I can just evaluate this. There's no discontinuity happening there. So because it is continuous, because this function is continuous at that point, the limit should be equal to the value of the function at that point. So I've got these two negatives all cancel with each other. So I've got 1/2 divided by root 3 over 2. So that gives us just negative 1 over root 3. All right, let's take a look at what's happening with this one. My gut feeling, well, I guess we could try and evaluate it first, but I'm seeing x to the negative 1 is the same thing as 1 over x. And so right away when I plug in 0, I'm getting an undefined value there. So let's continue to simplify it and see what we can come up with. So I'm going to rewrite this as 1/5 times 1 over x times 1 over sine x. And I'm looking at what happens as limit x approaches 0. Well, I know this is going to be approaching 0. I know that sine x is also going to be approaching 0. So that implies to me that we have a vertical asymptote here. And the only question is the function doing something like this, or maybe one branch is going positive and one branch is going negative, or maybe both branches are going negative. So we're not sure what's going to happen. So that's all we have to figure out. So far the limit might be positive infinity, it might be negative infinity, or it might be does not exist. Okay, well let's think about the left-hand limit and the right-hand limit separately. For the left-hand limit, these values are going to be negative. For the left-hand limit for this function, these values are also going to be negative because x is less than 0, so the sign x is also going to be smaller than 0. So that implies to me that the overall values should be approaching positive infinity. From the right-hand side, this is going to be positive and that's going to be positive. So again, as the denominators approach 0, their values will be positive. So from the right hand, I believe they should both be approaching positive infinity. So that tells me that the limit should be positive infinity. So here's our function, and as you can see, from the left hand and the right hand, the limit is approaching positive infinity for both functions. For both directions. All right, how about this one? Again, I'm going to start by rewriting because I see that when I evaluate x is 0, it's going to give me undefined values. So here I've got 1 over x. I'm going to write the 1/5 out here. This is 1 over sine x. So I'm going to go ahead and rewrite this section of it. I've got 1/5 times sine x over x, and this is all limit x approaches 0. As you recall, this is a limit we know. This limit equals 1. So the overall value of this limit should just be 1/5. All right, last one. If I rewrite this, I've got x sine x divided by e to the x. So I've just moved this into the denominator. So again, thinking about which functions are dominating here, e to the x grows so much faster than x that these values are eventually going to dominate those values. So this, as x approaches infinity, this entire expression should be approaching 0.